Okay, we are going to talk about controlling LED lighting for machine vision. There are a lot of things to consider when selecting how to power your light and a lot of options to choose from. So hopefully by the end of this webinar, it's just a little bit more clear which is best for your application. So to start off with, we want to understand our light, the LED properties, the types of lights, and that will help us know what kind of powering our LEDs, how it benefits us, and what it can change. So what makes a light? Lights are composed of arrays of LEDs. So in high quality lights, they're very precisely matched. This prevents individual LEDs from being stressed and provides more even illumination across the array. So these lights, they inherit their characteristics from a single LED. And lights are going to come with a rating for CCS lights. It's going to be their continuous rating, so it's going to be a 24-volt light with some type of wattage at the maximum. So this is their rating for continuous use of leaving the light on, all the time, 24/7, as long as the machine is on. The PF series, the Power Flash series, is gives you the rating as an overdrive light rating since it's an overdrive light. So it gives 48 volts and then the peak current in amps. You can get this same overdrive rating for kind of our standard lights. You have to reach out to us and we will provide that for each specific light. And then what you'll get is the peak current that you can apply to the light and the duty cycle you must respect while you do it, pulse period, etc. So if you're using a Gardasoft controller or a CCS overdriving controller, it's not as critical to know this information because those lights or those controllers have built-in safety. But especially if you're not using one of those controllers, it's important that you understand, what the overdrive rating is for each light so you don't give it too much power and burn it out. So next is talking about, essentially where are the brains in lighting? For lights like the FE Lux lights, they have what we call a built-in driver, which means that they have built-in control to change the illumination method and make changes to the intensity. So if you need to pick, if you need to change your intensity or change your illumination method, all of that can be done with just the light and a 24-volt signal, and you are good to go. You can pick whatever you want. Lights like the CCS lights, they have no built-in control. So if you want to make any changes to the illumination method or the intensity, you have to have additional equipment such as a controller, a CCS controller or a Gardasoft controller. So that's kind of going to be the difference between these lights is internal built-in control, all you need is the light and voltage signals to designated pins, or external controller with absolutely no built-in control, and anything that would change the light has to be done with additional equipment. There are a few LED properties that I kind of want to go through. They're not necessarily critical to knowing, which type of driver to do, but they're just more things to consider as we think about our lights and how we're using them. So LEDs are semiconductors that emit light when powered. Along with emitting light, they also emit heat. So as the junction temperature increases, the forward voltage is affected. And it actually, you can see here that the forward voltage will decrease as the temperature of the light increases. So that's kind of the theme for the next few slides, is just not letting your light get too hot. Overall, that's just going to make a lot more, just going to make some changes, but that'll come down to how warm your light is. When the current is controlled, the light output is constant. So when you're sending your current to the LED, there might be some fluctuation, with how much current comes to the light and like a little bit of fluctuation in that regard. But the output that you get from your light and, what the intensity looks like, what the uniformity looks like, that's going to be constant. So we want to control the current that we give our LED to control the output. And then LEDs have lifetimes. The way we describe the LED lifetime is by how many hours it takes the light to decrease from its initial intensity. So L70 means how many hours does it take to go from its initial intensity to 70% of that. If you just leave your light on constantly all the time, it's going to be much shorter, maybe 3.5 years. If you only have your light on while you're taking a picture, you can improve that, because your light isn't on constantly. It's not getting as hot because you're letting it rest in between images. So you can really improve the LED lifetime by not having your light on continuously. That being said, another benefit of having a controller or an internal driver is the ability to change not necessarily the LED lifetime, but the lifetime of your light itself. So if we set up our machine vision system and we set our intensity of our light to 80%, and that's still giving us a good image that's bright enough. Over time, our image is going to start getting darker and darker and darker, and eventually we're going to have to improve the intensity. So we can just go from 80% intensity to 90% intensity, and that's going to continue to give us a good image. But again, over time, all LEDs they'll get darker and darker and darker. We'll once again increase our intensity up to 100%, and then once again it'll over time darken up. And then once we're at 100% and our image is too dark, it's time to replace the light. But by starting at 80% and giving ourselves the ability to increase the intensity of the light by 20%, we gave ourselves a few more years with that light itself before we needed to replace it. So we're not necessarily changing the LED lifetime, but we are changing how long we go in between replacing lights. So that's just one kind of benefit of a controller right there. Circling back to temperature, the brightness can actually be affected by the temperature of the light, whether it's caused by the ambient temperature or the junction temperature. As it gets higher, the intensity of the light can decrease a little bit. It's not drastic, and we can see in this graph here, it's about 100-degree difference for a very small change. You're going from maybe 0.8 or 1.1 to 0.8, so it's not a huge change, but it is important to remember that not to let your lights get too hot. Another reason for that is the temperature can change the wavelength. As you get very cold, your light will have kind of a yellowish tint, and as you get very warm, it'll have more of a bluish tint. Another thing that can change the wavelength is the current. So a yellowish green tint will happen if you have a low current, and then if you have a higher current, you'll get kind of a bluish tint. And kind of the reason for why this happens, the way white LEDs are made is it's actually a blue LED with a phosphorus filter on top. That's why your white LEDs, your white lights look like they have kind of a yellow LED. That's the phosphorus filter. So when you have a low current, you don't have as much power behind that blue LED, so you kind of get that yellowish greenish color. And with a high current, you're giving more to that blue LED, so you get a bigger blue tint, more of a blue spike in that spectrum. Actually, the natural white LEDs that CCS invented came from optimizing the diode and the phosphorus to getting that more full spectrum. But, I don't want anybody to get too hung up on the relationship between, current and wavelength and temperature and wavelength, unless you're doing, an extremely precise color application. It's really not going to affect your image or affect, the way the machine vision light is working. So the takeaway from these few slides is to just make sure that you're keeping your light at a good temperature, not putting too much stress on the LEDs, and just understanding that LEDs have lifetimes. The cooler you can keep your LED, the longer it's going to last in general. So moving on to lighting methods, there is continuous and strobe, and then one form of strobing is overdriving. So I'm going to get into the difference between these and kind of when we want to use them. So the continuous light is where the light remains on while the vision system is in use, regardless of when the camera is taking an image. So the light is on while the machine vision system is on, and it's off when the machine vision system is off. This is by far the easiest method. The intensity is the only parameter that needs to be set. Just make sure you stay within, the light's rating. Don't give it 48 volts if it's a 24-volt light, etc. And it is easy to maintain the consistent light levels. So you'll see the intensity drop off more. You can adjust from 80% up to 90%. And so it's just kind of easiest to to see that happen as well. Next is strobe. The light flashes only while the camera is taking an image. So when the camera needs light, that's when the light turns on, otherwise the light is off and resting between flashes. This can reduce the average power that is needed, which will increase the life of the light. It decreases the on time that the light is on, giving it rest between, which also extends the life of the light. It helps with the thermal considerations. It can avoid needing to have additional cooling, whether it's, the light's just getting too hot over time, if your ambient intensities or your ambient temperature is too high. By strobing the light in quick flashes, letting the LEDs rest, you can avoid having to have some type of water cooling or fan cooling built into your light. And it just gives you more stability overall when you're controlling the temperature of your light. You can also use strobe to have multiple inspections per station, like photometric stereo or one bright field, dark field image, etc. And it allows up to 10 times overdriving for short pulses. So before I talk about overdriving, I want to talk about the different terms that you'll come across when you look at spec sheets of controllers and internal drivers. And, this is kind of a hard thing to describe because strobing is kind of a vague, overarching term of the light is flashing while the camera is taking a picture. But if you look at the spec sheets, you're going to see things like strobe, pulse, on-off, switched, and the difference between them is essentially the trigger signal that's controlling it. So if you're looking at a spec sheet for external controllers and you see on-off and switched, or you're using an internal driver, that strobe is going to be controlled by the trigger signal from your PLC. So if the trigger signal is high, the light is on, and the light will stay on until the trigger signal drops, and then your light will turn off. So this will have kind of more fixed parameters. You can't necessarily make as many changes since it's just based on the trigger signal. That's the only change that you can do is when the light is on and when the light is off. Versus if you're looking at like CCS or Gardasoft controller, their spec sheets, and you see strobing or pulsing, that means that you can set how long the light is going to be on and then just have one short trigger, turn the light on for that amount of time. So if my exposure time is 100 microseconds and I want to have my light on for 150 microseconds to make sure that my full exposure time is being illuminated, I will take my controller and go through the settings, set my exposure time or my pulsing time to 150 microseconds. And then my trigger signal can come from a sensor, as sensing the part go by, it sends a quick trigger signal to my controller. My controller then turns my light on for 150 milliseconds, and then the light turns off, and it does not turn back on again until my sensor senses another part and sends another trigger signal. So this isn't really going to come up for the rest of the presentation, but just when you're looking at products at CCS or even products from other companies, they're going to use different terms. And the difference is just how you power the strobe, whether it's related to the height of the trigger signal, high or low, or if it's something that you can set in the controller and set a fixed time. So moving on to overdriving, this is where we're actually taking the light and flashing it beyond its normal operating level, but for a much shorter amount of time, and we're allowing rest in between. We're allowing rest in between each flash. So the downside of overdriving is that you're putting more current onto an LED, so it has to have time to cool down so it doesn't get overstressed. So this is where we have to factor in and consider our duty cycle. So the duty cycle is the overdriving time plus rest time. So the more that you overdrive the light, the more rest you need. So if I'm overdriving my light at 200%, it needs to be a 30% duty cycle. But if I'm overdriving my light at maybe 500%, it needs to have or at 500%, I need like a 5% duty cycle. So the light can only be on for 5% of that cycle. So these limits are going to be based off of the controllers and the lights. So Gardasoft will have a table of, if you're using it from this intensity, 200 to 300%, respect this duty cycle, 300 to 400%, respect this duty cycle. And CCS, as I mentioned before, will also have overdrive ratings that we will provide when asked. So it's just important that you're making sure you're giving your LED enough time to rest between flashes when you're talking about overdriving. And I will say that, if you're using a CCS light with a CCS controller or a Gardasoft controller, you don't have to worry about overpowering the light. Both of those controllers have built-in safety features to make sure that as long as you're putting in the rating of the light correctly, you're not going to overpower it. Essentially, the controller won't even let you. So it's important to factor in and know your duty cycle, but it's not critical if you get it wrong on accident when setting up your controller. That being said, benefits of overdriving. You can freeze fast-moving parts, which I'll talk about in a quick second. You can override ambient lighting. So in that regard, we're having the light be so bright that it's overshadowing, if you will, any light coming from, the window or bright light overhead that's causing a hot spot or a glare or something like that. So we're just flooding it with so much light, we're overpowering any other light in the area. You can minimize pixel smear and you can improve your depth of field. So because we're giving this so much light, we can actually reduce the aperture on our lens, and that will allow us to have a better depth of field and get an image where we can get more of it in focus. So when I say freezing fast-moving parts, you can see these pictures here with continuous illumination. Our shutter speed has to be long enough to get a bright enough image, but you can see now that the image is very blurry and you're catching all of that motion. It's not necessarily it's not blurry in the sense that it's out of focus. It's blurry in the sense that it's moving. So that's kind of what we'll go into with pixel smear. So you can see with continuous illumination, it's not a clear image, but with pulsing overdriving, we're able to reduce our exposure time to be so fast that we can get a clear image where it doesn't look like it's moving. So that's kind of essentially what pixel smear is. So if you have 0 pixel smear or 1 pixel smear, only 1 pixel is allowed to be quote unquote moving. But if you have 8 pixel smear, that's where you get where it looks like the image is moving really fast underneath the camera. So that's kind of the benefits of overdriving, uses of strobe and continuous. Next, I'm going to talk about internal drivers versus controllers. So we have the scenario of having an internal driver. We have a specific scenario of having no internal driver, so a CCS light, but also not using a controller to get the brains. And then there's scenarios of a CCS light with external voltage controllers and CCS lights with external current controllers. So the internal driver, these are the FE-Lux lights. This is where we have the built-in brains, if you will, within the light. So you can adjust your intensity and control your lighting methods all within the light. So with this, you're able to do continuous, strobe, and overdriving. The advantages of having the internal driver, everything built into the light, is always going to be the cost. You're not purchasing your light and another piece of equipment. It just all comes together. It's going to be easier to use. All you need is something controlling 24 volts, giving an analog signal. You can have direct synchronization with cameras. You can plug the lights directly into a smart camera, for example. And they'll have built-in overpower protection, so you don't have to worry about overpowering your lights or anything like that. Disadvantages of this is the parameters are not customizable after purchase. So if you need your FE-Lux light to be a little bit brighter for a little bit shorter, you can call them ahead of time and request those parameters and purchase a light that's specifically for you. But if you just purchase an off-the-shelf light, you cannot make any changes after the fact. And the interface is not it's mostly applicable when it comes to the external controllers, but it's an analog signal. It's to change the intensity, you're gonna give it a range from 0 to 5 volts or 0 to 24 volts, and then to power light on, you're just gonna give it 24 volts. So I've kind of mentioned overdriving and all that. So the features of FE-Lux I'm going to talk about now, but before I start, I do want to say that these are features for FE-Lux specifically. Other companies will have internal drivers, and they'll have a internal driver that can overdrive the light, or an internal driver that can just turn the light on continuously at 100% intensity. They're all going to work, the same for the most part. Of 24 volts will power the light. But what I'm going to talk about for this slide is just unique to FE-Lux. So what FE-Lux has is they have this overdrive auto strobe feature, and essentially what that means is a trigger signal will come in, so your signal will be high, and for the first 245 milliseconds, the light will be overdriving at 450% intensity, and every light will kind of have a different one. The FE-Lux ring light has 700% overdrive. Different versions of the Flex have a different amount of intensity, but the auto strobe feature itself is the same, where for the first initial amount of time you're overdriving the light. If you keep your signal high after this amount of time ends, your intensity will drop to 100% and your light will be in continuous mode. So this is a fixed ratio. You can't change how long the light is or how the intensity is. But if you continue to just flash your light shorter than this duration, you'll always have your light in overdrive mode, and it's very easy to get overdriving from this light. You also have the adjustable strobe, and this is where you're strobing the light, but you're not necessarily at 100% intensity, and you can adjust that intensity via an analog signal. And then there's dimmable continuous as well, which is the light is in continuous mode, it's on, but you can again adjust the intensity via an analog signal. So for the for the FE-Lux lights, they have different dedicated drivers. So you can have one light that just has dimmable continuous, one that just has auto strobe, or you can have all of this built into one with the multi-mode driver if you don't want to pick and you just want all of your options. So now for the next few slides, I'm not talking about FE-Lux lights, I'm talking about CCS lights. So these are the lights that have no control built into the light. The brains, anything that's got a brain is from an external controller. In this specific scenario, I'm talking about the CCS lights, but not using an external controller and just giving 24 volts straight to the CCS light. It technically can be done. We don't recommend it because you can see here the disadvantages are much more than the advantages. If you do it, your light's only going to be on in continuous mode. It's just as long as the light's getting power, it will be on. It is easy and it is low cost because you don't have to purchase another component, but the downside, you don't get any intensity control. You don't have any tolerance for over voltage fluctuation. Your light is just, in general, more likely to overheat and burn out due to no protection, due to being on continuously. It's not good for the light overall, but it will work. And the interface, you don't have any, you're just giving it 24 volts. So now I'm going to talk about adding the brains, adding an external controller. So there's CCS will sell controllers, and they're going to be voltage-driven controllers. Gardasoft will sell controllers, and they're going to be current-driven controllers. So I'll kind of get into the difference between the voltage and the current and different models, but that's the difference between the companies and the controllers that they sell. So for voltage, this PWM is called pulse width modulation. That's where the light is always flashing at a very high frequency. It's faster than the frame rate, faster than our eyes can see, and you can change the intensity by changing the pulse width. So the pulse width here is how long the light is on, and then the frequency is how long the light is resting. Pretty much the duty cycle, really. So if you want the intensity to be longer, you just have your pulse width be, 80% and then on for 80% and off for 20%, and then you're going to get 80% intensity. So an advantage of this type of system is its linear intensity adjustment. As you're just dealing with the high frequency pulses, if you set it up to pulse width of 30%, your intensity is going to be 30%. So overall, you're getting a very stable light performance. And then the lighting method that you can do is just continuous strobe, so you can't overdrive. The disadvantage of this is the image may flicker with your shorter exposure times, and I'll get into that in the next slide. The interface for this one, the CCS controllers will all have a front panel interface, so you can see this intensity adjustment knob, and here's where you program it on the little screen. But it will also have another type of interface, so this one has an Ethernet port to do Ethernet communication. Some of them, if it's parallel communication, will have more terminals or some port for an RS-232 connection. So for CCS controllers, you'll have front panel and Ethernet, front panel and parallel, or front panel and RS-232. So I mentioned flickering before as a disadvantage. Here's what I'm talking about. For some very high-speed applications, your exposure time might be too fast, and what will happen is you'll have maybe 5 images that will look really great. Intensity is ideal, you're getting great images, and then maybe your 6th image is really dark and you can't get anything and you're getting false negatives or false positives. And what's happening is your exposure time is so fast that in one exposure time you're getting 2 pulses, but the way it lines up with your next exposure time, you're only getting 1. So that's why that 6th image has half of the intensity. A way to solve this is by strobing your light, so then every time you're taking a picture, you're always getting 2 pulses. It'll be much more even. If you haven't already purchased the controller, then maybe consider going with a faster controller, such as a current controller or something like that. Another type of external controller that is voltage is a voltage control. So instead of using pulse voltage that is pulsed with modulation, we're using voltage that is an analog signal. So we're changing the output voltage to change the intensity. The lighting methods you can get for the lower cost controllers are continuous or strobe. Advantages of this is it's often lower cost. You don't get the image flickering. The disadvantage, the light performance isn't necessarily stable. So as you change your voltage from 30% to 80%, it doesn't necessarily mean that your light is now going to be at 80% intensity. It doesn't go in a linear way like the pulse width modulation does. So it's a little bit less stable when you're changing the intensity. It's a little bit harder to get the perfect intensity in that regard. And then the interface you're going to have is front panel or Ethernet. Some controllers only have front panel and that's it. The one in this picture here has front panel and Ethernet. So next we have the Gardasoft current controllers. So these are done, you change the output current to change the intensity. So these Gardasoft controllers, they can do continuous mode, strobe mode, and overdriving. The advantages are the LED's intensity varies linearly, kind of like pulse width modulation. You just get generally more control with the current controller, so you have a precise control with a constant output. And with current controllers, they generally can have more high-speed capabilities. The disadvantage of this one, I put complexity, and that's true for Gardasoft. It's also kind of true for pulse width modulation, just by adding, or even the voltage controller, by adding another component into the lighting. It just makes it a little more complicated versus just having an internal driver. But another interface that you can get with Gardasoft, it's one of the 3. It's either Ethernet, RS-232, or possibly a front panel option. But that's kind of the difference between the controllers. Is internal driver, everything is with analog signal. Voltage, external controller, you have pulse width modulation where you're doing the pulse width is changing. You have voltage analog signal where you're just changing the voltage to change the intensity, and then current control, you're changing the current to change the intensity. So now I'm going to go into the pros and cons of each scenario. So when do we kind of want to use each type of driver? Is there a scenario where one is going to give you better results over another one? So first, to start with, you're going to go with whatever light the application needs. If a floodlight is required, you've got a really big field of view, you're going to use FE-Lux and you're going to use their built-in driver. But if your sample, your application requires a coaxial light, you're not going to try and make a bar light work just so you can have the internal driver. You're going to use a coaxial light and then pick whatever controller you want for that application. So first and foremost, all of it is light driven, and then after that you can make your choices if you can. So let's say the next scenario is you want to have intensity control, you want to strobe or use the light in continuous mode. There isn't necessarily one controller or one driver that's better than the other in this case. It's going to come down to preference. So I'm just kind of go through the pros and cons of each one's, where one, like kind of what their strengths are. So for CCS, we would recommend having pulse width modulation. The controllers we have front panel knobs, so they have really easy intensity adjustment. You don't have to have an Ethernet connection, but you can if you get the Ethernet model if you want to. And they just provide a lot of flexibility with how you can set up the strobe, how you can change the intensity, if you want to have it on off, or if you want to have it where you can set the strobe width, or the pulse width, if you will. On the other hand, FE-Lux's internal driver is very simple. Again, you're not adding that additional controller cost, so it's going to be lower cost. But you just connect the pin to whatever light mode you want on, and you're kind of good to go there. Gardasoft, they don't have any front panel controls. So in one situation, it's a pro that you want it, but Gardasoft, if you ever have a situation where your operators are coming into work and the machine vision system's not working, so they just go change the intensity of the light until it no longer yells at them, and then they can keep doing their job. Well, with the Gardasoft controller, there is no front panel control, so operators can't mess with it. Noted, on the CCS controller, there is a lock you can put, but it can be unlocked. Gardasoft controller also has flexibility. They have an Ethernet connection to control all of the components from a distance. They've got a really convenient GUI, so you can adjust the desired parameters from afar, all on one system. And they are Gigi and Vision software integrated. Gigi Vision and software integration. So that's kind of, again, not one is going to be better than the other. It's going to come down to preferences and what you want out of your controller more than what the application needs in this scenario. Another scenario is if you have multiple lights, but you're only looking at one application, so you have to sequence the lights. So what I mean by sequencing is either you have the part coming through, you've got multiple cameras looking at it, so you have multiple lights that need to be turned on. So you have camera 1 needs a top light, camera 2 needs a side bar light or something. You can flash camera 1, turn on light 1, then flash camera 2, turn on light 2. And those can be at different intensities, they can be flashing at different times, but sometimes there's more complex systems like a line scan system that's got one camera, but you have either different color lights or different bright field or dark field or backlight scenarios. So sequencing is just essentially having one light on, turning it off, turning another light on, turning it off, maybe turning another one on. So in this scenario, it kind of depends on what you're doing, but overall, CCS's pulse width modulation, they're going to be great for setting different intensities for each light. That front knob is really convenient for just saying, hey, I want my intensity level to be 100 out of 255 for the first one, 255 out of 255 for the second one. The PD4 can do photometric stereo, so you can set it up to have one trigger come in and it can, set off a sequence. For FELux's internal driver, it again is still simple. You're still just giving your 24 volts to the pins, but in this regard, you do need more of a PLC just to get the timing down to turn off one light and turn on another. But the cost is still going to be lower. Gardasoft controllers are great. They've got channels that go up to controllers that have up to 16 channels if you have a lot of lights in one application. They can also do photometric stereo. You can set your intensity. They have a lot of flexibility. Same with the CCS pulse width modulation. So kind of once again, not necessarily one is better than the other. It's just what you want out of the controller. So sometimes we have multiple lights, but we don't necessarily need to sequence them. So we really just need to make the intensities match. A good example of this is having, if you have a large field of view, you have a big flat dome light, but you also supplement with bar lights on the side for a more even illumination. Or if you have a real, a full dome light, but you have a camera hole in the middle, you can put a coaxial light on top of that. But if you just have both lights on at 100% intensity, that coaxial light is going to be way too bright. You'll have a really silly hot spot in the middle. So you just need to make sure that you can change the intensities of multiple channels. Very similar to the last slides. CCS's pulse width modulation is just going to be simple for setting the intensities, provide a lot of flexibility. FELux's internal driver, lower cost, just doing your 24 volts, maybe need a PLC, but pretty straightforward as well. And then Gardasoft, they've got that same controller with up to 16 channels, lots of flexibility there as well. So unfortunately, this isn't a scenario, neither was the last one, where I just say, obviously this is a current controller situation. Your preferences really do play a lot, and the controller you have isn't going to make or break either of these applications. For full color applications or full color or RGB lights, the lights that are sold that are full color or RGB are a little bit different. So FELux sells RGB lights, and their LEDs are going to be one red, one green, and one blue. And that's just going to repeat for the length of the light. But CCS, their full color lights, which the standard options are the HPR2 and the HPD2, is every LED can do red, green, or blue. So kind of pros for the CCS lights is you get a lot more uniformity because every LED is going to be having, if you just have the red channel on, for example, every LED is going to be showing red. So you get more uniformity at a shorter working distance. Versus FELux, if you have only the red channel on, every 3 LEDs is on. So at a short working distance, your uniformity might not be that strong. But the FELux light is a lot lower cost than the full color light. So it's a pros and cons, whatever your application needs. The point of a full color RGB light is if you have a lot of samples that come down the line, and maybe red light works for sample A, but then sample B comes and we want a blue light, then we can, without having to change the light or anything, we can turn off the red channel and turn on the blue channel. If you pick an FELux light, you just get the internal driver. This is the light that you get. If you decide to go with a full color light like CCS, the pulse width modulation is going to be great for doing the intensity of each method. And a Gardasoft controller, kind of the same. It's really easy to adjust with Ethernet connection. There's no reason to do current over voltage or anything like that. It's just preferences for driving the light on how it's going to interface with your own system. So now when we get to overdriving. So if you have a lot of options to overdrive a light, to be honest. CCS has our PF series for extremely high intensity overdriving. So the PF series lights are going to be, up to 10 times brighter than an overdriven light. So the kind of rule of thumb is if you're at 500 microseconds and above, you could probably get away with just your standard light. Between 500 microseconds and 100 microsecond exposure time, overdriving will probably work. but it might not depending on the application. And then as you get closer to 100 microseconds and below that, you pretty much exclusively need the PF series in that intensity. They also have the POD and the PTU2 for controllers that will overdrive, standard lights that aren't part of the PF series, because this is a dedicated light with a dedicated controller. But this is a time that I'll say current control is a better solution. So if you're not using the PF series and you're using a CCS light, we would recommend using a GardaSoft controller. So this provides the most flexibility in terms of the strobe time and the intensity. They have SafeSense built in, which is essentially prevents you from overpowering the light. So if you're playing around with your settings and you kind of forget to respect the duty cycle with your percentage of overdriving and your exposure time, the controller will automatically change the parameters to make sure you don't overpower the light and break it. So it's a really easy way to do overdriving. It gives you a lot of flexibility. Effilux, their auto strobe provides really easy fixed overdriving. So Pro is really easy to use and lower cost. Con is it's fixed. So if you need just a little bit more light, you can't get it, but it is a bright overdriven light. So you're still more than likely going to solve a lot of applications you come across. Line scan. So CCS has dedicated line scan controllers. Some of our line scan lights have dedicated controllers that have to be used with that light, but we also have controllers that are just for our other line scan lights. GardaSoft controllers, they provide kind of more stable power, and I would say in general are better for line scan lights. So if I had to pick, if you had a CCS line light, and I had to pick between a GardaSoft controller and maybe a CCS controller, I'd probably recommend the GardaSoft one. That being said, the CCS voltage controllers are great as well, so your preference can play in a big factor here as well. Effilux has their bar lights can convert to a line light, but they also have dedicated line lights as well. And these all have the same built-in drivers. You're going to want to use the continuous strobe, or the continuous mode, the adjustable continuous one, instead of the auto strobe version of the continuous for the best results. But overall, it's also easy to use and install and a little bit lower cost. So for line scan, it kind of matters, but it isn't critical to the application. For high-speed applications, this is very similar to overdriving, but I'm just going to elaborate a little bit more. CCS, the PF series, is ideal for extremely high-speed applications, sometimes if it's the only option, essentially. It has 1 microsecond response time. Effilux has a new logistics lights with extremely high intensity and really fast response times. This is also lower cost. And then GardaSoft, they have overdriving built in, and they have very fast response times as well. So if it's really fast and an overdriven, so if you're using a CCS light, the best option is a GardaSoft controller. If that is not bright enough, then step up to the PF series by CCS. If you're using a floodlight and maybe the standard bar light isn't sufficient for Effilux, need more light, then step up to the Effilux's logistics light for more intensity. And last but not least in our scenarios is dealing with smart cameras. So this isn't necessarily about controls per se, because I'm going to be talking about a CCS light, not a CCS controller. But our CCS lights, when you have an M12 connector, they can be connected directly to a smart camera, and the light will be on continuously. As long as the camera's on, the light will be on. If you want the light to sync with the camera exposure, so to strobe and flash while the camera is taking a picture, you can use our IFL cable, and that will allow the light to sync with that camera exposure. If you connect an Effilux light, because those have M12 connectors, directly to the smart camera, you'll get the auto strobe in sync with the camera exposure time. So you're overdriving the light in sync with your camera exposure. If you're using a smart camera and you want the intensity control and or overdriving, and it's like a high precision light, like you have to overdrive a coaxial light or overdrive a flat dome light, for example, like not just a standard bar light, that's when you would use your Gardasoft controller. It's also Gigi and GemiCam Vision compatible. One thing to note about connecting directly to a smart camera is the power consumption is limited to, I think, 1 amp. So you're either limited in the size of the light or you have to power the light separately, like for FE-Lux. So you would give the 24 volts and the however many amps you need from a power supply to the FE-Lux light, but you would wire it into the trigger signal from the camera. So just keep in mind that the power consumption might be a limiting factor. Okay, so for the most part, that's, when to use each controller. There's only a few scenarios that I went through where, Gardasoft is better than CCS, or CCS is better than FE-Lux, or FE-Lux is better than all of them. But a lot of it really just comes down to your preference and the interface that you want, and how you want to program it, and use your light. So it's kind of important to keep in mind, and maybe takes a little bit of pressure off that, you're not going to break your light because you used voltage when you should have used current or something like that. I will now go through kind of the questions we want to know to help pick the right controller, and kind of how to pick one with the CCS example. So when we decide that we want a controller, the information that we're going to ask you is, how many lights are you controlling on one controller? What are the lights? Because I need to know what the current rating is, the voltage rating, and the power rating of each light. Just to help narrow down what options is, what communication preference do you prefer, RS-232, Ethernet, whatever. I need to know if the application is in continuous or strobe mode. If it's in strobe mode, are you trying to overdrive it or not? If you're trying to overdrive it, essentially what's the duty cycle? How long will the light be on? How long will it be resting? Do you know how much more light you need? Are you overdriving at 200%, 400%, 500%, etc.? So all of this, I can, do the right calculations to make sure that not only are you getting the right controller, but that you're not getting an overpowered controller for your application as well. If you've decided that you just want to use a CCS controller with the CCS light, if you look in our catalog and you come across, you pick out the light you want, the power consumption will be listed, so 24 volts and 21 watts, and it will also put the recommended controllers. So in this scenario, the PD3 is the voltage pulse width modulation, the PSB is the voltage analog controller, and the POD is the overdriving controller. And so let's say we just want it to be pretty simple. We want to just control our intensity a little bit and maybe set up a strobe. We want to go with the PD3. So then you look at the spec sheet of a PD3 and you want to look for the applicable light unit. So it tells you the total for 3 channels, total for 4 channels, total for 8 channels. So you look at the number of channels the controller has, and then the total number of watts it can handle. And then from there you just kind of do the calculations I talked about a few slides ago. How many lights am I using? What's their rating? So I've got 2 lights at 21 watts, so I need a 42 watt controller. Number of channels is important, but it's not the only thing to consider. For example, the PD3 30243 has 3 channels. We only need 2, but the total power consumption is 28 watts, so it actually wouldn't be powerful enough. So we step up to the PD3 50244, which has 46 watts, which is plenty for our 2 lights. And then the rest of the part number is determined by the communication you want or the AC/DC input. So that being said, that is the webinar today. Thank you guys for tuning in. I hope that this was useful to you and maybe help clear things up about the difference between, what type of controller we need to use in what scenarios.